Hello and welcome to the Satellite and New Space Matters podcast. Your hosts today are myself, Callum Davis, and Laurie Scott, two members of the neuco satellite team. We're delighted to be joined today by the team from Aurora Propulsion Technologies, Pekka Blomberg, CEO, Aziza Ibrayeva, Commercial Lead and CCO, and Perttu Yli-Opas, CTO and Co-Founder. Welcome to the show, everyone. It's great to have you with us.
Hi, thanks a lot for the invitation. So excited to be here today.
Yeah, great to join.
Pleasure.
Thanks for joining. Really appreciate it. For our listeners that don't know, Aurora are at the forefront of in-space mobility, developing innovative propulsion technologies, including its water-based resistojet systems, helping to shape the future of satellite operations through propulsion systems that are more sustainable, flexible, and responsive than ever before. So to get things started, we always like to kick off with the same question. How did you all first get into the space industry?
Yeah, I can take that one. So I'm one of the co-founders. Really, the idea came from a university project where we were developing a small hybrid rocket engine and looking for something more commercial. And we ended up looking at the market and figuring that there's not really a market for something that you're launching off at the ground. Maybe if you go all the way to orbit, but that wasn't in our plan. So instead, we realized that actually there is a huge growing demand for very small propulsion solutions for in-space propulsion. So let someone else do the launching from the ground, and we'll move the satellites in orbit. And really, the trend is coming from the fact that satellites are becoming very much smaller. Now, in a way, we are starting to move in a little bit different direction now, but looking at CubeSats, actually more than 90% of them don't have any propulsion, which is largely due to the lack of actual availability of solutions. And there's a big need for more complex mission profiles and more capability. So we decided that, hey, let's start developing these miniature propulsion systems and enabling much more complex mission profiles on those microsatellite and nanosatellite platforms.
And Pekka, how did you first enter the space world?
Well, I've done a long career in defense and security business, and latest working on cybersecurity, and not really worked with space before. And then 2 years ago, I found Aurora and thought that this would be an exciting challenge to do something completely new, and was positively surprised how much it builds on everything that I've done before. So I've been now with the company for close to 2 years.
Fantastic. And finally, Aziza?
Yeah, for me it was a complete accident. I was living in Finland and working in a travel industry and hospitality, and then tried to pivot to a more tech industry, which I was very curious about. And at that point, ISI was a smaller startup, and they were looking for people who have experience in sales and not necessarily any space background, because they were willing to teach and share. So this is how I got a job from ISI. They called me, invited for an interview, and this is how I ended up. After all these trainings, understanding the whole industry, I got so curious and excited about that, so I never wanted to leave. And then I continued my journey in the space industry.
Interesting. It's really interesting to hear all the different paths and kind of avenues people have taken into the space industry. But yeah, exactly as you said, Perttu, it's interesting how many businesses come from university relationships. It makes me question what I was doing at university, where I wasn't starting a space startup. So moving into the next section, I'm going to hand over to Laurie, who's going to discuss and ask about the Aurora journey and how you founded the business.
Thank you, Callum. Yeah, so, I mean, Aurora has grown significantly since those early days. This is probably more for Perttu or for Pekka, but what's been the sort of biggest challenges that you face when building the company?
Yeah, I mean, for sure, balancing the kind of startups need for rapid movements, being able to change direction based on the market situation and the demand, with the demands of high reliability and high quality of the space industry, because it's just the fact that developing high reliability equipment takes years, and you have to be able to balance sensible quality practices and approaches that actually have a significant result on the end product with the ability to actually move in a more agile way, let's say, than the traditional space industry is able to.
Yeah, fascinating. And was there a particular decision, sort of milestone or a turning point that had the biggest impact on your success?
Of course, the changing of the space industry is kind of the biggest trend here. So when we founded, the space sustainability as a topic wasn't really being discussed that much. There was academic research on it, but it wasn't really visible in all of the expos and conferences around the world. But over COVID, this changed completely. Of course, mostly because Starlink started launching ridiculous amounts of satellites. So everyone realized that, hey, this is not something that is off like 50 years from now. It's something that is actually starting to happen right now, and we really need to start working on it. And that has absolutely changed the industry. And it's been very much exactly what we were predicting back in 2018 when we founded the company.
Yep. Fascinating. I wish I had some stocks in with them going IPO. I missed a boat there, but maybe next time I'll have to look at you guys. How have you seen sort of Aurora's evolved from those early days to where you are right now? I mean, I was very lucky to sort of see your demonstrations at the SmallSat Europe conference recently. Very impressed. But yeah, just sort of fascinating to sort of get your take from where you was at the beginning to where you are right now.
A large part of that is, of course, just moving from the initial technology demonstration missions of like the kind of minimum viable product type of things to something a little bit more complex, which is more customized to the customer, because now we are actually working with the actual customers and giving like active feedback from the customers on what is the actual demand, what are the actual requirements that they need, what matters most, and finding that kind of largest impact that we can do at the customer has been a big step forward. And maybe Pekka can comment a little bit on that side as well.
Yes, when I joined the company, then it was clear that the first phase, which was more like a technology development project, was coming to its end, and the products were starting to be ready, and a transition was needed to a more commercial company that has products, that is selling products, and not anymore more of a technology development, but rather a commercial product development company with a strong sales and customer voice that is then fine-tuning these products. And that's where we are at the moment as a commercial product company. And now we're then preparing for the next phase, which is something even bigger.
Yep, excellent. And then, I mean, my final question, maybe this is one for you, Aziza. I mean, the space industry has changed dramatically. I think we're in an exciting time right now, particularly with the investment we're seeing in space within Europe. My question is, how's Aurora adapted with these changes, and what are you seeing in terms of the key issues in the market that need addressing today?
Yeah, that's a very good question, and it basically addresses our recent course, change of course, or not actually a change of course. It's just the market caught up to already technologies that Aurora has, which is very high maneuverability, dynamic shifting, and then defense sector is becoming so strong in Europe, and especially in the past years. Seeing that Europe is uniting and having these lots of collaborative opportunities, I think Aurora's product is really good for the new trends and for the new demands, especially with the lots of investment in the defense sector.
Fantastic, excellent, fascinating. Yeah, I mean, it's a real sort of fascinating and interesting time in the market, and very excited by what we're seeing. So thank you so much for that. I'm going to now hand you over to Callum, who's going to explore a little bit more around the wider market and the dynamics that are shaping this industry.
Yes, and I understand that Aurora has recently pivoted towards a more defense-focused and dual-use position. Curious to understand what this really means in practice, and what was the reason behind that strategic shift?
Yeah, as I said, that we didn't. It's just the demand basically opened up for us in new vertical that where we already were quite good with having these small propulsion systems, and then addressing this lack of maneuverability. As both Perttu and Pekka has mentioned already, satellites without propellants, without propulsion systems, is just a sitting duck in space. And now all these demands is basically to make it move, to make it maneuverable, to operate in a way that that meets the demands from the new defense sector or capabilities. Now that you need to have a rendezvous and proximity operations, now when you need to understand what's going on the satellite that is very close to yours, and it seems like it's moving towards yours. Is your satellite is capable of moving away? Is your satellite is capable of doing something to protect itself? So here where Aurora comes, really, because we already were good at maneuverability. Our propellant is water, which is non-toxic, non-hazardous. There is no risk of explosion, and then it gives quite high thrust, high impulse, meaning that you can really shift very fast to avoid a collision or to to make your mission happen in a way you want it to happen, not being, caught up in a situation that no one wants to get in.
Mm. And has this had a big impact on kind of consumer and buyer behavior, specifically across Europe?
Yes, it shortened sales cycles. We see it from ourselves, from the orders we receive from customers, and we also, when we talk to customers, their end users, they also started asking for a faster delivery. And the other thing is it became, or the defense market became more open and more open for startups, innovative products like ours, for example. While, I don't know, like 10 years ago, it would take us a very long time to get to talk to people we're talking now.
Interesting. And how does that affect, obviously, developing your propulsion systems in a market that is constantly changing? From a technology perspective, how do you adapt to those changes?
Well, Perttu, of course, will be the best person to take this question. What I can add from my side is that at some point, we were a little bit nervous that satellites are becoming bigger and bigger and bigger, and our propulsion system serves a certain type of satellite. But then with the defense inquiry, we see that there is demand actually for smaller propulsion systems, because there is a certain types of satellites that are being built, and they need to be smaller, they need to be faster to build, faster to launch, and then the propulsion system, of course, needs to meet those expectations. We have the shortest lead time in the market at the moment, and also quite small, or actually we have the smallest propulsion system, which is just the size of a matchbox. But from the technical side, of course, it's better that Perttu covers.
Yeah, like Aziza mentioned, that the added requirements for like more complex capabilities are the biggest difference. But also the kind of sense of urgency in some of the missions where it's difficult because, of course, they still want to be reliable, but it's not very easy to be reliable in that kind of time scale. So actually what you need to do is start looking at redundancy and resiliency, not just reliability, which is a very different question as you are looking at what happens after a failure or in case of a failure rather than preventing a failure. And that's something that our technology has proven to be very effective at, because having the small form factor allows us to duplicate the whole system. We can even duplicate the whole propulsion system for the satellite, where some other solutions might not even fit in the first place. So even on a 1-unit CubeSat form factor propulsion system, excuse me, we have a fully dual redundant propellant system where there's no single point of failure, allowing us to actually keep operating even when any single component has failed, which is absolutely crucial for these mission profiles where that reliability and resilience is a major factor.
Yeah, makes total sense, and really difficult to stay adaptable. We've spoken briefly around one of the biggest buzzwords in the industry at the moment, in defense. It's become one of the fastest growing areas within the space sector. From your perspective, what are the key factors that are driving that momentum, and why is space becoming such a critical part of modern defense strategies?
Well, if I take that one, and what is happening in space at the moment is very similar to what has happened in other domains earlier. I was fortunate to follow the rise of cybersecurity some 15 years ago, where the world realized that everything revolved around IT, and IT was everywhere, and nothing would work without IT. And then the security and defense issues around IT emerged, and cybersecurity was developed. And now after over 10 years, then IT is relatively safe. We're doing the same now in space. We are realizing that space is connected to everything. Things on Earth don't work if space is not accessible, and that means that we need to secure space. And that will take a while to build that in, because it wasn't a design criteria back when the satellites were launched. Now it's a future design criteria for the future ones, but it will take some time before that is deployed. So that is definitely one thing that is creating this. So it's a natural evolution that defense in space becomes an issue. Now, in terms of the growth, I see two factors here that are very strong. One is that sovereignty. So we've realized that space has been very cooperative until now, and cooperation doesn't always work. So countries and regions are now stepping back and looking at what are their own sovereign capabilities in space, and realizing that there's not enough. So they have to build them, and that's going to take a while to build that. And that is definitely creating a market. And that, in addition to the fact that the assets in space are not secure by design, they need to be secured, either built in or then added on later. And this whole building secure space is something that is another factor that is driving the growth. So these are things that are driving us at the moment and creating a larger market.
And is it an obstacle kind of navigating different nations, kind of regulations and different rules that are put in place by different nations?
Yeah, I can comment on that. So to some degree, absolutely, having some national regulation only available in their national language can be difficult for us to play with. But luckily, most of the major kind of trend lines are similar. But essentially, as kind of the fundamental separate provider in the industry, because typically one provider builds the whole spacecraft except for the propulsion. Propulsion is something that is basically always procured because it is so different in terms of the core expertise that you need for the development, that basically it makes more sense to have a separate company do that. And at the same time, propulsion is the subsystem that is affected by the most amount of regulation, because all of the regulation on deorbiting or collision avoidance or whatever regulation it is typically on some level impacts the propulsion system. So yes, it's absolutely something that we are actively working on. Of course, our customer in essence translates the national legal requirements to actual technical requirements for us, but often the customer also doesn't have expertise in the topic, so we do have to dive into that. So yeah, there is absolutely something to be improved on the European level, where we could have the same rules for everyone. But as the work on the EU space law has proven, it's not very easy to come up with those rules that would be the same for everyone, because the demands and needs for each country and each kind of segment within the industry are quite different.
Interesting. And I know that Aurora obviously sits at the intersection of commercial innovation and defense applications. What are the biggest obstacles in navigating kind of sitting within both markets?
I think dual use is the key to success, in the sense that going for only one type of market or one type of application, it limits your scope a lot, and going for dual use then creates a wider market. Also, I would say the defense market very much appreciates that there is a commercial use case as well for the product, because it increases the volumes and reduces the costs and increases the development budgets that are available. So dual use is definitely a key word here.
And in terms of kind of for the future of kind of security and defense, how important do you see agile space companies like yourself playing a part in securing that kind of future of security and defense across Europe?
I would say that the solutions that are quite different from existing solutions are very difficult for the traditional industry to develop, because the approach that they have for the development might just be way too slow for such a different system than what they have developed previously, and especially in terms of the size. The traditional industry can do it in 1,000-kilo satellite, but if you want to launch 100 of them, they cannot be 1,000 kilos each. So there has to be a kind of class of small space companies that raise to the challenge and develop their solutions. In a way, it is a race to the first reliable system, because the reliability is going to be the number one challenge for these new companies. It is not easy to make things reliable. And that's why you do actually need multiple companies developing the solutions. You cannot put all the eggs in the one basket. And those that are actually able to make the thing work will then succeed.
If I may add something, I think small companies like ourselves have a critical role in being innovators. New innovations are typically created in a smaller context in smaller companies, and then if they are successful, then they of course become big companies, either organically or through mergers and acquisitions. So all good ideas end up in big companies, but they're typically created in small ones. And that's why it's very important that we look after these small companies and foster that innovative process that is ongoing. And we see that a lot, when we travel and look at other countries and regions, that each country is trying to create that same momentum to get the small companies going and interested in space and developing those locally, and then also protecting their local markets so that they would have their own, let's say, sovereign defense industry.
Yeah. No, I think you make a really good point in terms of protecting that innovation, because I think especially with requirements like sustainability, like we mentioned at the start, you really need that level of innovation to facilitate requirements like sustainability. Interesting. Well, look, we'll hand over to Laurie now, who's going to speak about Aurora and some of the work that you guys are doing.
Yeah, so it sort of follows on from the innovation, and just fascinating to hear you talk about how these smaller companies are really sort of changing the industry as we know it. So Aurora's has been a strong advocate for water-based propulsion systems. For our listeners who may be less familiar with the technology, can you explain what water resistojets are and how they work?
Yeah, absolutely. So in principle, it's a very, very simple technology. It's a space kettle. So we just put some water through a very, very, very hot pipe. It vaporizes into steam and jets out. And that's what then pushes the satellite forward. Well, in practice, of course, building that is a little bit more complex. The principle is effectively that simple, integrating a resistive electric heater to heat that pipe up to the temperature. So, of course, traditional rocket motors use a chemical reaction to heat up the gas to that high temperature. But in space, when you don't require that much thrust, you can just use electric power, which allows your propellant to be stable chemically and also much kind of easier to handle in terms of pressure, in terms of density, in terms of other characteristics. So water is just ideal for these use cases. And what we've developed is the smallest of the class. So there are some other water resistojets, but we are at more than 10 times smaller mass for the actual thruster tip, which actually does all of the work. So we are able to install much more of those into the same satellite.
Brilliant. Yeah, and well, I mean, I love the kettle analogy. Yeah, I get it. So water propulsion, it's attracted a lot of attention in recent years. What is driving the growing interest, and why do you think the technology is now gaining that traction?
Yeah, in addition to the things I just mentioned about like the let's say water being easy to work with, it's also very versatile in terms of the propulsion technologies that you can use. Because on top of that, the resistojet technology, you can also use electrolysis to actually split that water into hydrogen and oxygen, and then burn it in a chemical rocket engine to create much, much more thrust. It's limited with some other factors, but in larger systems, this can be a very good strategy for certain maneuvers. In addition, you can use those hydrogen and oxygen for a Hall effect thruster, which is all going to be able to create very, very large total impulses at a very low thrust level. So basically, you can make large orbital changes over a long time. And this allows you to actually have kind of this full economy of using water as a propellant, because it can cover these all kind of three main domains of propulsion, which are high thrust chemical, medium thrust, medium impulse, kind of versatile propulsion, and then the high total impulse, low thrust propulsion. This allows, for example, the emergence of in-orbit refueling, where water is going to be the propellant to be refueled. It's again very easy for the refueling, let's say, mothership to function with, but also it can use it for the orbital changes. It can refuel multiple satellites with completely different mission scenarios with the same propellant.
Fantastic. And I mean, as mission requirements continue to evolve, particularly across defence and dual use applications, these water resistant jets sort of help support and provide that greater flexibility and responsiveness in orbit. So yeah, that's super helpful. So that now sort of ties in nicely to the commercial impact. So beyond the technical advantages, what are some of the commercial implications of this technology, and how is it sort of changing the way the operators think about satellite mobility?
Pekka, go ahead.
Yeah. Well, I think when we talk to satellite integrators, then very often we are faced with the response that propulsion is difficult and dangerous, because you have these dangerous chemicals and it's difficult and they don't always work and so on. with water and resistojet, we introduced something that is much more safe and secure and much more reliable. And this then, let's say, lowers the defenses on the integrator side to incorporate it in their systems. Then, of course, then there's also the customer demand that their customers that are looking for that satellite service, they want more mobility in the satellites for adaptability in the mission.
Fantastic.
To add to that, so one of the details that is often not appreciated is actually the ground logistics as well. Because shipping a satellite that has chemical propellants is almost impossible, especially air travel. So typically you need to actually go to the launch site to fill the tanks of your satellite, which can add tens of thousands of cost and a lot of effort for a small team, especially on the CubeSat level, where you might not need to go to the launch site in the first place otherwise. We actually are able to ship our systems pre-fueled. Everything is fueled. We've even sealed the fueling port by welding so that we have a secondary seal for these ports, which is typically companies cannot actually have dual seals for all of the fuel ports. And this just allows for a large kind of streamlining of the integration of the propulsion, because you don't need all of these additional steps after the integration. You just install the system into the satellite and it's ready for launch. That's it.
Yeah, and this is why procurement team really loves working with us.
I bet, yeah, reliability is obviously critical in the space industry. With the space industry, I mean, particularly space mobility, it's evolving. How do you see the next 5 years and the role for the propulsion systems are going to play in enabling the future? Because it feels like it's changing on a daily basis.
I think that propulsion and mobility will become standard. It hasn't been set standard, especially in the small satellites earlier. Big satellites have had more propulsion built in, but the smaller ones haven't. You simply haven't had the space or the technology available, and it will become standard, and it will also become a requirement. So you could say that there's no walking on the motorway in space. Everything needs the ability to move. For collision avoidance purposes as a minimum, but definitely for the mission as well, you need to be able to adapt your orbits for your mission, and your missions will change, especially as satellites typically have longer lifespans. Then it's difficult to forecast what you need to do with your space sats in 5 years.
Yeah, if previously the only propulsion system people usually thought about was for station keeping. The only reason was like station keeping. Now it's more and more in demand collision avoidance. But now when we are moving both into the defense applications and also to more robust space ecosystem, like lots of investment into the space data centers. I know when I talk to people about that, everyone is just rolling their eyes saying that it's too far, it's unrealistic. But hey, look, we're here right now, and 20 years ago, for example, people would never think that they were going to be such a small satellites at the LEO and being launched every a few days, right? And so with this, having this propulsion system for maneuverability, for collision avoidance, for actually have some operations in space, and then for understanding what the surrounding in space, what is it that you need to approach or avoid, is something very, very important. And for example, for me, I had no idea that satellites are flying so far from each other, although everyone is talking about a LEO being contested, and that they're like very high probability of collision, and yet they're quite far from each other. So we're going to shorten that distance. And if now satellites usually stand or or fly a few kilometers from each other, and it's already quite close. We're moving towards having hundreds of meters and then having very, very close outreach, and then being able to do something with another satellite, for example, refueling or some service provision for commercial and civilian uses, right? But also it opens up so many opportunities for the defense sector.
Yeah, it really does. And I spoke about it a little bit earlier. I was very impressed with the demonstrations, with the size, the matchbox size propulsion system compared to some of the other ones. And I mean, you've got that fine balance of production and delivering the speed, because everybody wants it yesterday. But I think from my side, the propulsion market is very competitive, but the landscape is evolving. Where do you believe sort of Aurora differentiates itself from other providers in the market today?
I think when you buy your first propulsion system, you very much look at the technical specifications, and that's of course where you might see more alternatives, and you need to win, of course, that battle in sense of specifications. But then in the long run, as you buy more propulsion systems, you start to value your customer experience and the service provided by your provider. And this is something where we see big differences. And many companies have said that they've gotten poor service on the market, and they're looking for better partners for propulsion, and that they really want to work with us because we have a good support from beginning to end of the mission for their system. And I think this is something that will bring the customers back over and over again to use our systems.
Yeah, and it's for the post sales, right? Having all these supports coming in personally for the integration, for the commissioning, being with customers for the commissioning, and also following through the schedule very, very strictly. It's something that's important. I think this is also something from excellent Finnish engineering side that comes in this company, that being strict with the schedules, being on time is something very important. And then being really supportive, understanding that we are experts in the propulsion system and our customers don't have to really worry about that because we're taking all responsibility, we're taking all the care about the propulsion being built, delivered, and integrated, right? So it's something that's very important for everyone who works with us. And surprisingly, we have some customers who used to work with the bigger propulsion companies and switched to us, because for them they were just a smaller satellite manufacturer which makes like 6 satellites per year. And maybe it's not enough for bigger corporations, but for us, of course, it's a very valuable client. And maybe it's also coming from the hospitality industry, understanding that customer service, customer relationship is very much important. This is how we build our strategy for winning customers.
Amazing. I mean, it's fascinating, both the technology and the future, particularly for Aurora. I'm super excited. So thank you for sharing your perspectives. Real good insight. I'm now going to move away from the industry. I mean, the three of you and the Aurora team are working incredibly hard. For our listeners, keen to get a little bit more of an understanding around you outside of work. How do you switch off, all three of you? We'll go one at a time, but what's the perfect weekend for you outside of working and all the sort of innovation that you're being involved with?
Well, I can start. I'm a windsurfer, so when I'm not working with space, I'm out at sea and away on a windsurf board. So that's where I feel free and disconnected from the world and leave everything else behind.
Excellent. And nobody can contact you, even better.
Exactly. If my phone rings, then I'm really busy. I can't answer the phone right now.
And there's a little bit of a rivalry here because I am actually a kite surfer, so I'm also out to the sea, but with a little bit different equipment. So very similar approach for both of us. But yeah, it's absolutely just amazing to go out there and get on the water, and kind of the freedom that you get from moving with just the power of the wind, and being able to basically go anywhere and forget everything that you need to contend with in the everyday life is very much a freeing experience.
Excellent. And some competition between the both of you? Excellent. And then finally for you, Aziza.
Well, I'm more, closer to the ground. I like boxing, kickboxing, and yeah, and basically just doing sports.
Amazing. Brilliant. Excellent. And to continue this piece, I think Callum's going to do a bit of a quick fire round. I know we've caught you off guard here, but I'm going to hand you over to Callum before we've got one final question.
Yes, it's going to be a little bit of a shift from water-based resistojets, but we like to do a bit of a quick fire round for our listeners, really just to get to know you all as best as possible. So first and foremost, what is your go-to karaoke song? We'll start with you, Pekka.
If you want to sing, you can as well.
I don't do karaoke, so it would be difficult to find a song that I would start with. But I know that some of us do. So
maybe better to ask better to ask you, Perttu.
Yeah, I mean, it requires very specific circumstances,
yep,
but
of course.
I'm gonna go with the Phantom of the Opera. That's a classic.
Oh,
is it the full outfit and all? Yeah.
Typically.
Awesome. And Aziza, to you?
Well, I didn't have any, but after the movie Hail Mary, now with this Harry Styles song, it's really stuck in my head.
Ah, lovely. Yeah, always classic. And very quickly, kind of late nights or late night out or cozy night in. What do you prefer?
That's a tough one. There's depending on the situation, I do prefer spending time outside and doing activities with friends, but not that much to the pub. So not the classical one, but yeah, especially with the Finnish summer, the sun going down around midnight. Then, for example, going kiting until late night is absolutely amazing.
Lovely.
Well, for me, after a hectic week, I prefer to relax at home with the family and a home theater.
Oh, very nice. What's your favorite? Is there a particular TV show or film that's on at the moment?
Well, when the kids were younger, we were watching a lot of children's movies, but now it's getting more mature the material, and of course, getting the kids to watch it with us is getting also more seldom. But yeah, different historic movies. I think that's
lovely. Interesting. And finally, Aziza?
I don't have that much for free time. I'm doing MBA at the moment, so usually evenings and weekends are kind of filled with home tasks and pre-assignments. But when I have time, and I really try to protect these small windows, I'm preparing for a Hyrox, so then I go and train for this Hyrox thing. But yeah.
Yeah, it looks very intense. That's it's an interesting kind of way to switch off. And finally, if you could all live anywhere, I know that Finland is an amazing place, and you probably wouldn't want to leave anytime soon. But if you could live anywhere in the world, where would it be?
Ooh, that's a good question. I used to live in Maldives, so I think sometimes during the winter I want to return back and live there.
I could think of worse places.
Not for a long time.
I would very much like to spend some time in Kenya, actually. I've visited once and it was amazing, and there's an intersection of a lot of things that I like, and it would be very, very cool to spend some time there.
Awesome.
Yeah, I've traveled quite a bit, and the place that I really enjoyed was Australia. So I do understand why a lot of people have ended up.
Yeah, it feels everyone in my generation is heading out to Australia, and none of them seem to be coming back. So I can understand that. And very finally, in terms of your dream dinner party guest, is there anyone that you can think of, present or in history, that you'd love to have at a dinner party?
Oh, Neil deGrasse Tyson. I would really have
Yep.
would like to have more for dinner. That would be such an interesting conversation.
Yeah, interesting. And Pekka?
Well, I'll aim high and go for Barack Obama.
Amazing.
Yeah.
This is shaping up for a really an interesting dinner party. And finally, Perttu?
Yeah, Obama is a good one. I'm not coming up with anything good. Maybe of course, something from the history of rocket science would be interesting to
Yep.
hear the stories of how kind of the early sciences were developed. Maybe even back to Tsiolkovsky, who developed the original rocket equation, or back to that kind of profiles. But then maybe actually one very interesting guest would be Feynman.
Interesting. Yeah, this is sounding like a very high level dinner party. I'm going to hand over to Laurie, who was our last question of the podcast, which we always like to keep the same.
Yeah, so I think for all three of you, really, what would be your one piece of advice that you can give somebody that's entering the space industry?
Well, I would say that don't be afraid of the space industry as being something different and difficult. There's as a business, it's very similar to other businesses. It's becoming more and more mainstream, and there's a huge demand for let's say experience from other industries to really build this up as a business with the same types of working processes that you have in other more mature industries. So don't be afraid of space. Join us.
Love it. Excellent. Next.
Yeah, I mean that's the thing that the key is to just find a something that really suits yourself, and then apply that to the space industry. The space industry shouldn't be really kind of the content matter in a way. It's the environment, and the content matter is up to you. It can be basically anything. You can do anything in the industry, and that's what gives it very interesting aspects, because people from so different backgrounds can come to work in the industry. One of my favorite examples is actually ISI having hired relatively early days already seamstresses for the multi-layer insulation, because when you have to actually build complex three-dimensional patterns of two-dimensional surfaces, then people who would be better at that than people that are used to working with fabrics. So maybe those people that when they went to the seamstress school, they didn't imagine that they would ever end up in the space industry, but that's possible.
Yeah, I love that. Excellent. Last but not least, to you, Aziza.
Yeah, well, of course, my advice would be connected to the commercial angle, and I would say that learn the whole value chain and develop your network. That's where the leverage is. It's incredibly important, and I think people from the technical side don't really value that enough.
Love it. Brilliant. Great pieces of advice. Thank you so much.
Yeah, certainly a lot for our listeners to consider, really about entering the industry. Well, Pekka, Aziza, Perttu, thank you so much for joining us today. It's been really interesting to hear about Aurora's journey, your perspectives on the evolving space, and also the defence landscape in particular, and also really the exciting work that you're doing to shape the future of in-space mobility. It's been a real pleasure having you all on the show. Thank you so much.
And all the success.
It was a pleasure being at the podcast with you guys. Thanks for the invitation.